North and South, these two concepts have long been associated by many people with cold and warmth. Residents of the Northern Hemisphere are used to it, the North, the colder, and the South, the warmer. But what about the North and South poles? Which one is colder? Let's find out using accurate scientific data, and at the same time try to understand why this is so. To begin with, let's figure out where it is colder and how much. First of all, it is worth noting that the cold pole on our planet is located at the South Pole. In 1983, the Soviet Vostok Polar Station recorded a temperature of -89 degrees Celsius. In the North, in winter, the thermometers drop to a temperature of -26, 43 degrees, and on average about 40. It's not hot at all. But in the South, this indicator is even lower, the average winter temperature, that is, June-August, because we are talking about the Southern Hemisphere is -58 degrees. In the summer, the situation is still significantly better. At the North Pole, the temperature rises to 0 degrees, and on especially warm days it even reaches +2, +5. In the South, everything is noticeably worse. Here the air warmed up to -12 degrees in December 2011. It's usually much colder here. So, it's safe to say that although it's very cold at the North Pole, compared to the South Pole it's just some kind of resort. Why is the South Pole colder than the North Pole? The most obvious and expected reason is height. After all, most of the Arctic lies almost at the same level as the sea. All of it is one huge glacier, rising only slightly above the surface of the ocean by 2 to 3 meters, and even less in summer. But Antarctica is a full-fledged continent. Just from above it is covered with a huge layer of ice about 800 meters thick. Of course, the higher the temperature, the colder it gets. But this is just one of the reasons. It is worth mentioning the sea separately. The North Pole is surrounded on all sides by the ocean, and it is an excellent heat accumulator. Due to water currents, heat spreads relatively evenly, and the ocean warms the air at least a little throughout the Arctic. The situation is quite different at the South Pole. It is hundreds of kilometers away from the nearest sea, so the air masses have almost no effect on the local climate. This means that they cannot warm the cold air. Finally, astronomy also has a certain influence. Even in summer from September 23rd to March 23rd, the sun never rises to the zenith, as it happens in the Northern Hemisphere. On December 22nd, the day of the summer solstice, the sun reaches a height of only 23.5 degrees. As a result, the sun's rays falling at such an angle, and even on a white snowy surface, are simply reflected, very slightly heating Antarctica, leaving it cold and practically lifeless. To understand the structure of a snowstorm, you need to first remember why it rains. Probably not everyone remembers this well from the course of the school curriculum. Of course, the main factor is high humidity. After all, clouds do not necessarily form over seas and oceans. As we were most often told at school, moisture evaporates from the surface of rivers, lakes, and even just gives off to earth, trees, bushes, grass. It rises with the flow of well-warmed air upwards. If a strong wind blows, then the humid, warm air is simply blown away. If the weather is calm, then the air is saturated with moisture. More and more a cloud is created. The drops are already ready to spill down, because the further away from the surface of the earth, the colder the air. For some time, microscopic droplets are still kept from falling, thanks to the streams of warm air coming from below. At the same time, the smallest droplets rise to the upper part of the cloud, receiving a positive charge. The larger, heavier ones remain in the lower part and already have a negative charge. Moreover, the potential difference can be simply huge and reaches 100 megavolts. Where does such a charge come from? It turns out that everything is from the same sun, which spends a huge amount of energy on Earth every second. However, the clouds simply cannot be saturated with moisture forever. When the concentration exceeds the permissible limit, it starts to rain. It is accompanied by lightning and other spectacular special effects. Now let's try to imagine a cold winter. The humidity is much lower here, at least because moisture does not evaporate from the frozen ground. And in general, cold air carries much less water. It simply falls off as condensation in the form of snow grains, or ordinary snow. In addition, the earth warms up very little. Of course, there are no warm updrafts. This means that even if the air masses with high humidity came from somewhere and did not wake up as snowflakes, there would be nothing to lift them up. Finally, solar activity in winter is very low compared to summer. Therefore, clouds cannot accumulate a serious potential difference, which means that there will be no lightning and thunderstorms. An ordinary snowfall will take place, but in some cases, snowfall is still accompanied by a thunderstorm. Why? That's exactly where the data obtained at school is relevant. Air masses come from large reservoirs. Most often these are warm seas, but in some cases there may also be large lakes. The air above them is not only relatively warm, but also saturated with moisture. This is where the cloud is formed, the lower and upper parts of which have different potential. A strong tailwind drives the cloud for tens or even hundreds of kilometers. This is how it gets into a cold climate, mixing with cool air masses. If the temperature here is not too low, then the clouds will pour down with ordinary rain, causing a lot of problems for local residents. If a warm cloud falls into an area with a really cold climate, then a real thunderstorm begins, lightning flashes, spending a huge amount of energy. Because of this, water droplets, falling down, have time to freeze and turn into snowflakes or snow grains. This is how a snowstorm turns out, a rather rare natural phenomenon. Did you know that when trying to walk in a straight line, a person inevitably begins to walk in a circle, rather quickly straying from the original course? Moreover, this happens both when blindfolding and in the absence of at least some visual landmarks. Why is this happening? Scientists put forward a variety of hypotheses. We will try to deal with them, and at the same time tell you about the most plausible ones. It has been known for a long time that a person cannot walk in a straight line without having certain landmarks. And relatively recently, researchers working at the Max Planck Institute decided to conduct an experiment trying to figure out the causes of what is happening. For the purity of the experiment, people were blindfolded and offered to walk in a straight line through a fairly large area in the forest. Each of them had a GPS tracker with them, which allowed them to track every step. As a result, they began to walk in circles, laying out quite difficult routes. Moreover, if some moved at least somehow, then others began to circle from the very beginning of the experiment, making several circles, crossing their own routes several times. But the subjects who were not blindfolded were able to walk almost in a straight line. There were deviations, but relatively small. Then the experiment was repeated, but now people were offered to walk through the desert in the southern part of Tunisia. In the Sahara, 2 people walked during the day and showed pretty good results. There were deviations, but in general the route turned out to be almost straight. The third subject went out at night. At first, while the moon was shining, he walked almost in a straight line. But as soon as the Earth's satellite disappeared behind the clouds, the participant of the experiment immediately lost his way, made several circles and almost reached the starting point. At the same time, all the subjects were confident that they coped with the task perfectly and walked almost in a straight line. And if they deviated from it, then only slightly. It is definitely difficult to say about the reasons for this. Scientists put forward different versions of what is happening. Some believe that the problem is the asymmetric structure of the human body. For example, it is believed that one leg is slightly shorter than the other. Perhaps the difference is only a few millimeters, but if you walk several kilometers or even tens of kilometers, even such a small deviation gives a certain result. Other researchers believe that the same asymmetry is the case, but the uneven distribution of human organs is put forward as the main reason. Indeed, the heart, liver, kidneys and other organs have different weights, are higher or lower. Therefore, the right side of the body may well weigh more or less than the left. As a result, having no landmarks, a person walks in circles due to the uneven distribution of mass. There are other theories. For example, they put forward the theory that different parts of the brain dominate in different people. This was the reason why it was impossible to walk blindly or just without landmarks. As long as a person has a landmark, for example, a road, houses, the sun or the moon, they walk in a straight line, perhaps without even thinking about it. The subconscious mind does everything for the subjects. As soon as the landmark disappears, you have to rely only on your own feelings or even muscle memory. Because of this, the person begins to circle. This is proved by the difference in the correctness of the route in cloudless and cloudy weather.